Next presentation will be Wytse Dassen. He is working with the urban water management sector already for 5 years. And well, he studied also in Delft at TU, systems engineering, policy analysis and management. And well, he has obviously a passion for water, and now and also bringing people together from different sectors. And, well, he is interested in complex water projects, and currently manager of this this HydroCity-project, right? And your presentation will be about this project. Okay, go on.
Correct. Well, thank you. My name is Wytse Dassen. I'm a consultant at Hydrologic, so I have the role of a consultant. And I like to give you an insight what's already available here in the Netherlands, commercial-wise. I'm very honored to give you a presentation today. It's all nice to see you here in the Netherlands. I will do my best to keep 15 minutes. I have less slides than my other people, so that's a good start, I think. All right, HydroCity. It has started as a project, innovation project, but already becoming a commercial platform, an open platform for innovation with other countries, with other partners. So it's also the product is also an information portal like the other two have. So last year, in 2011, we won a prize, a small business innovation research prize, together with other companies to start looking in more detail to the urban water management. So my other speakers, they talked more about big dike breaches. I'm talking about what's the effect of a lot of rain in the city. Where does it go to, and where are the problems? And I can say, for now, there is much work to do. We just saw all the reports from Sandy that the water is still not controlled. If the dike breaches, it has a lot of problems because we don't take into account behind the dike what's happening. But also in the city, we experience extreme drought conditions. Also in the Netherlands, a country where there's a lot of water. I think at the beginning of 2011, we had actually a shortage of water in the west of the Netherlands. It sounds strange, but it's true. Also, in 2011, we had Brisbane in Australia, and the left under is about the water quality. Also, a lot of work to do. Urban water management changes now. It's already happening. The technique and the ICT solutions are there. And a lot of Dutch cities already use these techniques to make their city climate adaptive. So make sure your system can handle these really heavy rainfalls in the summer by not only making bigger pipes under the ground, but also taking subsurface solutions like green roofs, water squares, and stuff like that. And we do it not alone. We do it with a lot of friends together, because you need a really good network and a specialized network that everybody plays his role and accepts his role, being the best in what he does. And for every project, you look for friends and help your customer the best way you can. We also work with knowledge institutes, consultants, and we have some launching customers, mainly municipalities in the Netherlands. We have a quarter of the municipalities and half of the water boards use some part of HydroCity. So it's already a really nice result, I think. All right, it all starts with the data. Because if you don't have any data, you don't know what's happening in your system, so you don't know what kind of solutions you have to take to be able to transform your city in a climate adaptive city. So it sounds very logic. So in HydroCity, we work as an information chain. You need all these steps to help your customer, to help the municipalities in their urban water management. So you have to organize all these aspects of the information chain. So first you have companies that collect data from satellites, from urban water sensors, from radar techniques for rainfall forecast. They are very good in collecting them, validating them, and put it on a database. And these are accessible for other companies to make models, to put knowledge in these, to use this data and put knowledge in it and make, well, for instance, complex models for infiltration and runoff in the city. So step 3 is these very difficult models, you have to transform them and really user-friendly application, decision support systems, to be able to communicate with other stakeholders like an urban planner or people who take care of traffic or trees or stuff like that. You have to be able, as a water manager, to talk with them, and you have to give them the tools to do that. And of course, you have to train them to use these tools properly. All right, really short overview how it works. So you got a lot of different sensor techniques. There are companies who use these techniques and put it on databases, and other companies use these databases to create apps, to put their knowledge into apps. And apps is, well, a user-friendly, able to communicate with other stakeholders. So how do we do that? Well, this is a traditional information network. It's well, a spaghetti of links between databases and dashboards, and well, it's very complex and not very scalable. So we need a new structure, and well, it looks like this. You got a lot of dots in the world, and you connect them with one together with one portal. So we got a three-layer approach. So first one, you got data, all different databases, and the key is to keep that database at the owner of the database, because only he knows how good this data is. If you pass data to another person, he cannot validate, he cannot see if it's a good data, and if he uses it and it is bad data, well, he probably gives not good recommendations. So with our vision is keep the data as close as possible to the person who owns it, but make it available using web services. So in that way, it doesn't matter where it is, you can always reach it by internet. And then you need a semantic information model that's able to locate all these data and knows that data source A is called different in this database, that you manage this here. In the Netherlands we have some standards here, the AQUO standard, and also the municipality organizations are already also developing their standards. So it's very essential for this to work that all governments are, how you say it, demanding that their databases are open, using open standards. And that's a very long way to go, I think. But we have to empower them to say to these companies, make web services. Because then, companies like we do, HydroLogic, can make very smart applications, because that's what we like to do, to use difficult models, but present them in a user-friendly way. And if you keep this apart from each other, it doesn't matter which portal you use, because it's all standalone. So we don't want a Samsung and an iPhone situation. We like apps that can be used in any portal, also the speakers before. Now I have 3 movies about how the system works. This is called the data viewer. We have connected with 3 databases using web services. I can extract the data from one database. This is, for instance, the amount wastewater I pumped. But I also can use how much rain there has been fallen. So the end user, the urban water manager, can extract data from different databases and combine them to create information. And if you want to see this combination of data for your daily use, you can save it and put it on your dashboard. And that way you're able to do your work more efficiently. And you can also put other data in your personal dashboard that you already use, maybe some kind of internet sites. So very helpful and already used by 100 municipalities. All right, my next movie is a smart application about precipitation. Yes. So we got different applications, and one is the radar precipitation data using radar and ground stations. It's very simple, but it looks very simple, but the technique behind is quite complex, and it's developed by us the last 12 years. So a water manager can really quickly see 1 hour after the rain has been fallen how much it was fallen. And he can use these graphs for communication with the public or to the mayor maybe, and also collects the data to use your models and create models using real data and not national standards. And I have a third movie. And how long do I have?
You've got a few minutes left.
All right.
2 minutes.
So if you use the rain together with all the locations of the gullies, and you got a 3D model of your city using very spatial, using all the buildings and the trees in the area, using very detailed height models, you can actually see what's happening with a raindrop, because a raindrop that falls on a tree will almost never hit the ground. And if it hits the ground, it will infiltrate or not. And if it starts to flow, it flows to a gully or a low-lying area in the city. And all this we have put in a new runoff and infiltration model. That's the next movie. So here you see a part of Amersfoort. It's in the middle of the Netherlands. So we used all these models. We used a new model to put real data in it, and you can see all the locations where the water will collect in the streets. And this is already a nice picture, but it's actually, again, the data behind this is also really helpful, because it gives us a real good estimation where does the water go. Does it go into the sewers? Does it go into the ground? Does it stay on trees? And if it goes in the sewer, which gullies are used more than others? Can I have my next slide? Yes. So the really big dots gives us an estimation which ones are used more than others. So in your operational management, you can choose to clean the big dots more often than the other dots, so you can reduce costs. For the long run, if you renew the streets, you can choose to remove some gullies or put some extra there where there are really big red dots. So with more insight in what's happening with a drop of rain, we can ultimately transform our city to an climate adaptive city. Again, we work with other big companies that also have some applications on the portal. Last sheet, some tips and tricks for you guys. Tips and tricks. Trucks. Keep data close to the source, because only these people know what's happening with their data. And if they can combine, they will see that some data is, well, maybe bullshit. So they will start investigating in the field what's happening with my system. So we hope that the data viewer you just saw introduced these guys to go outside and look actually what's happening with their system, because now they are getting a lot of data and they actually do not a lot with it, because it's very difficult to handle such big information. So the second is use web services and open data standards, so we can benefit as an information chain together and we can make big steps forward. The third one is, the approach of open innovation together with partners has been very successful. The innovation project will stop this year, but we will continue to provide commercial products, but also room for more innovation and put it in the store, the app store, so that customers can see what kind of ideas are there, and they can adopt an idea, pay for it a little bit, maybe together, to make this application work. And make sure you have a lot of users, so it's also something you build that's used in real life, and not something that nobody will use. And I want to thank these municipalities for their providing the case studies. So again, urban water management changes now. Thank you for your attention.
Thanks, Wytse, for your presentation and especially the tips and tricks. There's time for a few questions.
Everybody wants coffee.
Question here.
Just for curiosity.
Yeah, please stay up and state your name. Yeah.
I'm with Siemens. Just for curiosity, to which extent do you assume actually the precondition of your soil or of your city? So if you start with your precipitation model, I assume it makes a difference whether it's coming from a very dry or from a pretty wet state.
Yeah, if you start modeling a real event, you have to set the parameters for infiltration or roughness of the area. So the saturation of the ground is taken into account. Yes, that has to be done by the expert who will use the model to make these visualizations. So answer yes.
Any more questions?
From Hong Kong, will you consider using data warehousing to help centralize all the data, and for future data mining purposes, the data warehousing, will you consider using it instead of keeping the data close to the source?
Yes. So we don't encourage a really big data warehouse. Only if it's possible for the end users to go into the data warehouse and readjust the data if he likes. But if it's only pumping data to a big warehouse and then the data is somewhere else, I think in the long run it's not sustainable.
time, but forecasts will be quite difficult to make because you don't know where it's going to rain.
Yes, in HydroCity we have one subject. It's called the International Radar Composite. So we use radar techniques to and we have managed to also use the German and the Belgian radars to collect a really nice, how do you say, where is the rain? But we also can forecast. We call it the nowcast. It's 90 minutes forward, and it gives an amount of rain every 5 minutes per square kilometers. So, and that's the detail you want for a forecast. So I predict that within 1-2 years we can take real-time control using nowcast.
Okay, thanks, Wytse, for your discussion.
Yes.
And this concludes our session on information portals. I'd like to thank us for their presentation, and we will have a 30 minutes coffee break now. See you around. Thank you.
Nice.